Hi guys, today's video is on linear inequalities. So linear inequalities are essentially the same thing as a linear equation, like what we've been doing, but instead of using an equal sign, it's going to use an inequality symbol. So I'm going to go ahead and write that here. So it's similar to a linear equation, but has an inequality symbol, not an equal sign. So remember, an inequality symbol is something like, and I'm going to go ahead and do that up here, when we have greater than or equal to, or less than or equal to. So those are what an inequality symbol is. So it's a linear equation with one of those symbols, not an equal sign. When we did linear equations, our solution was an ordered pair, right? We could either do it graphically, we could do it using substitution, or we could find it using elimination. When we find a solution to a linear equality, it's all the ordered pairs, which is just a coordinate, but it's all the ordered pairs. There's many solutions that make the inequality true. So they're all the ordered pairs that make the inequality true. So it says determine which ordered pairs are solutions to the linear inequality below. So it says 2x minus 3y is less than 15. So we're given an ordered pair there, right? 2 and comma 5. So remember, 2 is our x coordinate and 5 is our y coordinate. And we're going to plug those in to 2x minus 3y is less than 15 to determine if it makes a true statement or not. So we're going to plug them in where they belong. So where there's an x, I'll put 2. Where there's a y, I'll change that to a 5. So if I rewrite this, it would be 2 times x is 2 minus 3 times, and our y coordinate is 5. So if we finish solving this, we'd get 4 minus 15 is less than 15. 4 minus 15 is negative 11. So is that true? Is negative 11 less than 15? And yes, that is true. So yes, that is a solution to our linear inequality. All right, I'm going to jump over here and do 3, negative 4. So again, this is our x coordinate and this is our y coordinate. And we're going to plug 3 in for x, and we'll plug negative 4 in for y. So let's go ahead and rewrite this. So our inequality was 2x minus 3y is less than 15. So my x I said was 3. My y I said was negative 4. All right, so if we finish solving this, 2 times 3 makes 6. Negative 3 times negative 4 makes a positive 12. So we have 6 plus 12 is less than 15. Well, 6 plus 12 is 18. Is 18 less than 15? No. So 3, negative 4 is not a solution. All right, go ahead and try this one that says 0, 0 on your own. So determine if 0, 0 is a solution to our linear inequality 2x minus 3y is less than 15. Plugging 0 in for both x and y. All right, it says graphing a linear inequality is a way to show all ordered pairs that are a solution. So steps to graph. It says put the inequality in slope intercept form, which we've been doing for a while now. Remember, that's y equals mx plus b. So it's going to look very similar to that. Of course, it's not going to have an equal sign. It could look like y is greater than mx plus b, or y is less than or equal to mx plus b, that sort of thing. So essentially, you're solving for y. All right, it says be sure to flip the inequality symbol if you multiply or divide by a negative number. So we talked about this when we did inequalities a little bit ago. When you're solving for y, if you have to end up multiplying or dividing by a negative number, you need to make sure it flips your inequality symbol. All right, so to graph the line, there's some important steps. You're going to use a solid line for having less than or equal to or greater than or equal to symbols. You're going to use a dotted or dashed line if you just have less than or greater than. So an easy way to remember this is it's solid if that line is underneath. Like think about, there is a solid line there, right? So you're going to draw a solid line when there is a solid line underneath your inequality symbol. We're also going to have to do some shading. So we're going to shade above the line we draw in when we have greater than or equal to. We're going to shade below the line if we have less than or equal to. All right, so let's do an example. So we're using the same inequality. 2x minus 3y is less than 15. And I need to solve to get this y all by itself. All right, so we're gonna first have to move this 2x to the other side. Since it's a positive 2x, subtract 2x from both sides. 2x minus 2x cancels. I'm still left with negative 3y is less than. On the right side of our inequality, we have a 15 and we have a negative 2x. So I can't really combine those because they're not like terms. So I'm going to rewrite it negative 2x plus 15. Remember, we want the x first because we're essentially wanting it to be y, some inequality symbol, mx plus b. So we want that x first. All right, our last step here would be to divide by this negative 3. And we have to divide everything by negative 3. Remember, when we divide by a negative, it flips our sign. So it was less than. It will now flip to greater than. Negative 2 divided by negative 3 is positive 2/3. So I have a positive 2/3 x. 15 divided by negative 3 would make negative 5. So we're going to graph this. All right, so just like when we graph lines, you're always going to start at your y-intercept. So that's starting at the B, the last thing, the thing not touching the x. So I start on my y-axis. All right, so I'm going to count down 5. Put a dot. And then I have to move my slope. And my slope is a positive 2/3. So from that dot, I'm going to move up 2 and right 3. So up 2 and right 3. Now, to figure out how I'm going to connect these dots, I have to look at my inequality symbol. It's just greater than. It does not have the line underneath it. So it's just this. So it says to use a dotted line when it's just a greater than or just a less than symbol. So because it's just a greater than, I'm going to draw a dashed or a dotted line through those points. So draw a dashed line. Okay, the last step is we also have to figure out how we're going to shade. So it's a greater than symbol. So greater than says that we need to shade above the line. So we're going to shade above because it's a greater than symbol. So I'm literally going to shade everything that is above this line. So anything above that line is a solution to this problem. All right, so on this next one, we are going to start at our y-intercept again, which is negative 5. So go down 5 on your y-axis, put your dot. So again, that's where you're going to start. The number that's touching your x is your slope, and this is how we move. So if it's 1/3, we're going to move up 1 and right 3. So from that dot, go up 1 and right 3. Up 1, 3. And then I would also do the opposite, and I would go down 1 and left 3. So down 1, left 3. So then we have to think about, do I need to connect this with a solid line or a dashed line? So it's just greater than. It doesn't have the line underneath. So we're going to do it with our dotted or dashed line. So connect your dots with a dashed or dotted line. And then the last thing you have to do is think about, is it going to be shaded above or below? So it's greater than. So if it's greater than, it means you're going to shade above. And this is just something you'll eventually kind of memorize, but greater than is above, less than is below. So that would be our solution. All right, go ahead and try number 2 on your own. Remember to start with your y-intercept and move your slope. All right, on number 3, it says 5x minus 2y is greater than 12. So we need to solve this for y first. So your first step would be to move your 5x to the other side. Since it's a positive 5x, we're going to subtract 5x on both sides. And we end up getting negative 2y is greater than negative 5x plus 12. The last thing I need to do is get rid of this negative 2. So I'm going to divide everything by negative 2, since that's like negative 2 times y. But remember, when you divide by or multiply by negative, it flips your sign. So it was greater than, and now it's less than. Negative 5 divided by negative 2 is a positive 5 over 2x. And then 12 divided by negative 2 is negative 6. So it's now in slope-intercept form. So I can go ahead and graph it. So my first dot is going to be at the negative 6. So I'm going to count down 6. Put my dot. And then I have to move my slope, which is this 5 over 2. So I'm going to go up 5, right 2. Up 5, right 2. Up 5, right 2. All right. It is just less than, not less than or equal to, so it's going to be another dashed line. And on this one, it's less than. So less than means to shade underneath your line. So that would be my solution, everything that's highlighted yellow. All right, go ahead and try number 4 on your own. So get that solved for y first. Then plot your y-intercept and move your slope. All right, my next one, number 5, says x minus y is greater than or equal to 8. So I need to solve that first to get the y all by itself. So I'm going to subtract my positive x and put it on the other side. I'd be left with negative y is greater than or equal to negative x plus 8. Then I'm going to have to get rid of this negative in front of that y, which remember, that's like a negative 1. So I'm going to divide everything by negative 1. When I do that, I end up with y. I divide it by a negative, so I have to flip my sign. Y is less than or equal to, a negative divided by a negative makes a positive 1x, and then 8 divided by negative 1 is negative 8. So I now have y is less than or equal to x minus 8, and I can go ahead and graph it. So I'm going to start at negative 8. So down negative 8. My slope is just 1, so that's just telling me to go up 1 over 1. Up 1, right 1, up 1, right 1. Or I could go down 1, left 1. It's less than or equal to, so on this one I am going to draw a solid line. Again, that little line under there is kind of what is a key indicator that you need a solid line. It's less than, so less than means I shade underneath my line. If it would have been greater than, I would have shaded above, but it's less than. All right, go ahead and try number 6 on your own. I will help you get it set up here though. So of course your first step is going to be to get that y by itself. So you're going to have to move this 3x to the other side by subtracting. So we'll have 2y is less than negative 3x plus 0. And then I'll let you finish that off. So finish solving that for y and then graph it. All right, last 2. So number 7 says y is greater than or equal to negative 4. So This is just either, we know it's either going to be a straight up and down line or side to side. We have to remember. So remember, y equals anything is going to be side to side. If it's x equals, like number 8, it's going to be up and down. So since it is less than or equal to, that means I need to draw a solid line, and it's less than, so I have to shade below. So I'm going to find -4 and draw a horizontal line. So this is where y is -4. And then you're going to shade below that line. So your answer is anything less than or below -4. All right, so go ahead and try the last problem, that x is greater than 7. You should have drawn a line straight up and down at 7. And it should have been dashed because it was just greater than. If something is bigger than it, you're going to have to think, would I shade to the left or to the right? If I need values that are bigger than 7, I'm going to shade to the right. All right, well, that concludes your video on solving a linear inequality. If you have any questions, let us know.